going on, guys? In this video we are going to see an example of reduction of orders. Here the question is asking, given t square is a solution to t square y double prime plus 3t y prime minus 8y is equal to 0. We have to find the another solution. To find the another solution, what we do is we put the given solution like y2 and we multiply a function v of t, the function of t, v is a function of t, multiply by t square. Okay, the next thing is we had to find out y prime, y double prime and apply in this equation. Okay, let's go ahead and find y prime and y double prime. Y prime is going to be, since this is v and t square, two function of t, we are going to use a chain rule. In that way we will get t square v prime plus 2vt. Okay, and then we have to take the derivative of y prime because we need second derivative, because we are going to substitute y prime, y double prime in this equation, and then we are going to solve for this. Now y prime we found out already. Now the next thing is we have to find out y double prime, so we have to take the derivative of this one again. Now here v is a function of t and t is a function of t square is a function of t, and here also we have two functions of t, so two of them are going to be chain rule. So we are going to get four things like this. So if you find the derivative of this one, you will get t square v double prime plus 2v prime t plus 2v times 1 plus 2t v prime. Okay, now we have y double prime, y prime and y, so we can go ahead and plug everything in this equation and solve for it. Okay, first let's go ahead and plug t square y double prime, t square y double prime. Let me erase this. T square, actually t square v double prime. Oh no, I'm looking at the wrong thing. This is the one we are substituting. T square y double prime. Y double prime is this whole thing. Okay, here first we have to see whether we have any like terms. If you look at this one, 2v prime t and 2t v prime is same thing. We just rearrange this v prime and t is the same thing, so we can add them together. So in this way we will get t square times t square v double prime plus 2v prime of t and 2t v prime is all together is going to be 4v prime of t, v prime t, and then we have 2v left, so 2v, that's for y double prime. The next thing is 3t times y prime. 3t times y prime is t square v prime plus 2vt, t square v prime plus 2vt. Okay, the next thing is we have minus 8y, y is equal to vt square, minus 8 times vt square. Okay, here when we do the reduction of order, the first thing we have to know is that all the v terms will cancel. All the v terms should be cancelled. If it's not cancelling, it means there's something wrong. You have to double check it. Now let's go ahead and expand this one. This is going to be t power 4 v double prime plus 4v prime t cube plus 2v t square plus 3t cube v prime plus 6 v t square minus 8v t square. Now here all the v terms should cancel. 8vt square, 6vt square, 2vt square. Okay, so we have v terms cancelled. If it's not cancelling, there's something wrong. You have to double check it. Okay, here it's cancelling, so we are in a good position. Let's go ahead and continue. So this is going to be t4 v double prime plus 4v prime t cube, and then the next thing is 3t cube v prime, that's equal to 0. Now in reduction of order, what we do is, okay, let's see whether we can simplify this one furthermore. Here you can see again we have like terms. We have 4v prime t cube, 3t cube v prime, so we can add them together. If we add them together, this is going to be t power 4 v double prime plus 7 v prime t cube is equal to 0. In reduction of order, what we do is we put another terms like w and we equate this one to v prime. If w is equal to v prime, then w prime is going to be equal to v double prime. Okay, then we have to substitute in this equation. Instead of v double prime, we write w prime. So t power 4 w prime, and then instead of v prime we put w, so plus 7w t cube is equal to 0. Now w prime can be written as dw by dt, and also to bring this one into standard form we can divide everything by t power 4. If we divide everything by t power 4, we will get w prime plus 7 over t w, that's equal to 0. Now we have w prime plus 7 over t w, that's equal to 0. The next thing is we have to see whether it is separable, or we have to find integrating factor. We have to decide which one we are going to do. Let's expand this one. Instead of w prime, I can put dw by dt plus 7 over tw is equal to 0. Here this one looks like this can be separable. Let's see. Let's continue right here. So here we have dw by dt. I keep this one in this side, and I bring this 7 over tw to the other side, so this is going to become negative 7 over tw. Now you can see this is separable, so we can separate and integrate. If we separate this one, this is going to be negative. We don't have to bring the negative, I keep the negative this side, so 1 over w dw, and in the other side if we bring this dt, this is going to be negative 7 over t dt. Now we just try to integrate both sides. Integrate this side, this is going to be w, actually ln of w. If you integrate 1 over w, that's going to be ln of w, and if you integrate the other side, this is going to be negative 7 ln of t plus a constant. Let's call this constant k1. Okay. Now the next thing is we have to get rid of this ln, so we put e power. All of this thing we are trying to find v. That's our purpose. Okay, that's why we have to get rid of all of this ln and solve for w, and after that we have to replace the w with v terms and solve for v. Then we have to multiply that v with t square and find out the second solution, because first solution is given, second solution is what we are trying to find. So here we are powering e power ln w become w, and then e power negative 7 ln of t. We cannot get rid of this e in this way. We have to move this negative 7 to the power, so this is going to be t power negative 7, e power ln t power negative 7, that's going to be just t power negative 7, and here k1, this is going to be e power k1. So instead of e power k1, we can write another constant. Let's put k2 t power minus 7. Okay, now we have written the solution in terms of w. Now we know that w is equal to v prime, so we write this one in terms of v prime right now. Instead of v prime, we can also write this one as dv by dt. dv by dt is equal to k2 t power minus 7. Okay, now it's look like we can separate again, so we just have to move this dt to the other side. If we move this dt, this is going to be dv is equal to k2 t power minus 7 dt. Now we can integrate both sides. If we integrate dv, that's going to be just, this is just 1, so if we integrate 1, that's going to be just v, and here k2 is a constant, that one remains the same. But if you integrate t power minus 7, you add 1 to the power, so t power minus 6, then you have to divide by the same power, so 1 over minus 6. So instead of 1 over minus 6, I put k3 for that constant. Okay, altogether k3, and then t power minus 6. That's it for this one, and we have to add another constant plus k4. Okay, now we have this one, v is equal to k3 t power minus 6 plus k4. Now we found out v is okay, but y2 is v times t square, so we have to multiply this term by t square. Let's go ahead and do that. So y2 is going to be v is k3 t power minus 6 plus k4 times t square. In that way we will get k3 t power minus 4 plus k4 t square. Okay, this is our solution. One of the solution is given already. That is here. That is in the question. This is the new solution we found out by doing this reduction of order. T power minus 4 is the new solution. So finally we can write the general solution of the differential equation, like y is equal to c1 t square plus c2 t power minus 4, and that's going to be the general solution of the given differential equation. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn this differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.